Right, we're back out and about today in our beautiful deciduous woodland. Let's have, wait there. Listen to that crumple. Listen to that crumpling of those leaves. Look at this is beautiful. Look, we're back under this tree. Now, I'm not going to be as succinct as I can. I think you've noticed that. I'm going to go over some details of our nutrient cycle here while I'm out and about. Dog's with me. Where's the dog gone? Causing bother to other dog walkers. There she is. Right, but I'm not going to be succinct, and I think I just made that clear again. But I am going to go into detail. So I've noticed that there are some younger year groups following along, which is fantastic, brilliant. But I'm going to come out with some words now aimed towards our GCSE students. Doesn't mean because we have high expectations of everybody, you shouldn't be looking these things up. You shouldn't be spending your time outside of our curriculum doing a little bit, because this is fascinating stuff. Because remember, the world is a wonderful place. Now, here we go. This tree, we're autumn, beautiful big oak tree. Interesting to mention, just for the crowds here, that if we want to measure the age of this tree, you may know that we can cut it, we can count the rings, we can look at the rings for other things as well. That's called dendrochronology. But we can also measure the girth of it. We can take a tape measure, we can measure around it. And on average, a tree is going to grow about 2.5 centimetres in girth every year. So every 2.5 centimetres, we can get a rough idea of the age of a tree. And clearly, that's more than 100 years old, definitely. Some trees, like a yew tree, which is evergreen deciduous, quite interesting tree. You find them in graveyards. They're quite slow growing. Lottie, come here. Leave them alone. It's not your ball. Tennis players losing their ball. There she is. Was it not yours? Was it not yours? Okay, let's get on to the nutrient cycle. So what we got is this tree represents... Lottie, come here. She's going to go a third time, mate, and then it's her ball. You better find it quick. Okay. So this is biomass. This is biomass. This is where all our biological being. It's a tree. Yeah, it's wonderful. Now our biomass is in our leaves. It's in our roots. It's in the woodiness of the tree. It's in our plants. It's in our animals. It's everywhere. But our biomass. Now in autumn we're getting a lot of litter from here. We're getting the leaves falling off, and that's our beautiful crumpling sound underneath. And those nutrients that were in our biomass are now being kicked about by me and the dog. Now, other ways of nutrients getting onto this ground is through rainfall. We're going to get dust, we're going to get particles, we're going to get nutrients in the air. When it rains, that's going to come down. When there's a thunderstorm, we're going to get nitrogen that's broken within the atmosphere, within our troposphere, our lower part of the atmosphere. That's going to be in a position where it's fixed to something on the ground then. So those bonds, those strong bonds in nitrogen, which we're more nitrogen in the air than anything else, but it's useless until we put enough energy in it to break it up. Okay, so now we've got our litter. This is our second store from our Gersmahl diagram. We've got a litter. Now that's going to be go through decomposition by decomposers. Now mostly decomposers are looking at organic matter, maybe a spot of feces here and there. We have detritivores. Vores mean the type of thing that they eat. Now detritivores, they're going to go for your dead animals, your decomposing other things and everything. Just like a herbivore will go for plants. We'll also have a carnivore eating other animals. Look, this dog's trying to eat Lottie now over here. He's not, he wants to have a play. So we have those different types of organisms breaking down our litter. Where I've shown you videos where I've been on a river, we've seen leaves flowing downstream. Now where the leaves flow downstream, that would be seen as surface runoff or channel runoff. So that's taking nutrients away from our system now. But decomposition is going to put them into our next Gersmahl store, which is the soil store. That's where our nutrients go. Now, this is where our roots and our plants are going to uptake these nutrients back into their biomass. But before that, we could have weathering inputs. We could have more nutrients joining us from like the parent rock. So that rock type from below or sides or wherever. If our roots go deep enough, they're going to get at those. Equally, when I talk about depth of where our nutrients go, we can have leaching. So a fluid like a water body could take that deep out of the reach and back into the rocks, out of the reach of our roots and such, and those nutrients have gone to the point where we can't get to them. So inside these leaves, here they are. We've got to grab some, can't go out and about. Yummy. Right, inside these leaves we've got potassium, we've got nitrogen, we've got phosphorus, we've got magnesium, we've got lesser ones. Now, if our soil in our down here, if our soil is lacking any major nutrients, then unfortunately it's not going to be able to progress, it's not going to be able to grow very well. But these leaves, if you look here, let's get a close look at these. The point wasn't a lack of nutrients in our biomass while these leaves fell. It was climatic. It was climatic. Our sun was getting lower, production was going down and such. Wind even was coming up. This beautiful big oak tree here, this is well anchored to the ground, but even these can take a battering in the UK. But this is the point. The bond between the leaf and the branch, yeah, it gets weak at this time of year, and that's why they're all going to fall. Yeah, it's that low production, it's that strain on our ecosystem, our deciduous ecosystem here. I have noticed something just as I've been talking, quite an interesting one to finish us off. I'm going to back up a little bit. Look at that, I can still walk backwards. That's a skill. Okay, more PE than anything, I think. Okay, let's have a look back here. Take a good look at that tree. Now, behind it we can see that that evergreen, that conifer, that's coniferous. Look over here. Can you see my arrow there? My finger. Over here, zooming in, we can see there's loads of leaves over this side and not over that side, over this side. Now I know, being a local, that the sun is mostly in the sky over on that side where those leaves are. Now, I don't have a definitive answer to this. This is the sort of thing that we want you to, as a geography global thinker, as somebody that's interested in our environment, somebody's interested in connecting it to other things, to our human existence. But this is that curious mind we're looking for. Why are the leaves on this side of the tree and not on the other side? Now, an educated guess would say, look, we're getting what I just said about our leaves going weak because of less production. We're getting more sun on this side, but that's definitely something that's worth looking up. Definitely. Because isn't the world a wonderful place? Yes, it is. It is a wonderful place, and we've just seen that it is. I'm going to go now. This was over 8 minutes this time. I must have got excited this morning. Okay. Goodbye for now.